Welcome, one and all, to the Cool Worlds podcast with me, your host, David Kipping. This week, we're doing something a little bit different. Now, usually, as regular viewers and listeners will probably realize, I speak to my guests in person. So normally we're in the same space, the same room. I can see their reactions and feedback off them in real time. But today, I'm going to be doing a virtual interview. And normally, I'm very strongly opposed to virtual interviews because I do think you get so much more out of a real life conversation. But I guess today just wasn't available for an in-person conversation, fortunately. So the best I could do was have a virtual chat with them. And because of who it was, I decided it was worth doing that anyway. So the reason I mention this is because I am curious, before I introduce who the guest is, what your reaction to this style of interview is. If it doesn't bother you at all and you think this conversation is just as productive as any other ones we've had in person, that's actually useful for me to know. But if you prefer the in-person ones, then that's also good for me to know going forward, so I can really maybe put a harder line on that when I go forward with future guests. So we're going to introduce our guest. That is Nick Bostrom, who, of course, is a philosophy expert. He's a professor of philosophy at Oxford University, but I think we probably know him in popular discourse for his writings on AI, the existential risks of AI and superintelligence, the simulation argument, and maybe less so in popular discourse, but I'm certainly aware of it, his great work on anthropic reasoning. So anthropic reasoning is actually a topic I'm deeply interested in at the moment. I've been doing a lot of work and research that kind of touches on this, but applying it to astronomy. And indeed, cosmology has long been using anthropic reasoning with things like the cosmological principle, which is by extension the mediocrity principle, the Copernican principle, which comes into use in astrobiology. So these ideas have sort of bled down and have become a core part of some of the reasoning in science and astronomy as well. So I definitely wanted to spend some time trying to better understand Nick's take and whether his thoughts have evolved on that topic in this conversation. But of course, I think the thing that many of you probably have heard of with Nick's writings is the simulation argument, which of course is the basis of the movie The Matrix and many of the popular sci-fi adaptations, I'm sure. And in this idea, of course, it's a fairly disturbing one that we all might be living inside a giant computer simulation. And Nick was the person who really put down a kind of formal, rigorous argument to justify why this could be the case. And I've written a little bit about this in my own research, but Nick's really the expert on it, so I'm going to defer to him in this conversation. And I know that many of you, not all of you, but some of you, are really unsettled by the consequences of this argument. Some of you maybe just completely ignore it and say, I don't like that, so I'm just going to completely throw it away. I'm not going to ingest it into my my personal philosophy of the universe. But I do think some of us, when you read Nick's writings and you take it seriously, it leaves you with an unsettling taste in your mouth at the end. Like, oh my God, like, is this real? Could we all be living in some computer simulation? What does this mean for my life? It is an existential question. So I definitely wanted to talk about that in this conversation as well. Of course, there's a lot more I could talk to Nick about because he's worked on so many interesting topics. And unfortunately, we only had about an hour for this conversation. So please, I do apologize. I know there's probably many burning questions you have for Nick that I just simply didn't have time for in this conversation. I hope we can get him back on. If this conversation goes really well and lots of people view it and watch it, hey, maybe we can persuade Nick to come back on and go a little bit deeper into some of this stuff. So if you like this episode, please do, share it around widely, share it to your mom, share it to your friends, and get people to watch it because that really does make a difference. So without further ado, here is my conversation with Nick Bostrom. It's really a pleasure to have you on at last, Nick. I've been following your work for a long time, so I'm really grateful for the opportunity to talk to you today.
I think it'll be, I mean, I've seen some of what you've done. It's like interesting stuff. So
Yeah, and I thought a common place that obviously you are sort of the master of this is anthropic reasoning. And it's something I've been getting increasingly interested in my own research. It, of course, has a long history being applied in science and especially astronomy and cosmology. So I thought maybe we could start there and maybe you can just explain to the audience what is anthropic reasoning and what kind of problems is it really trying to solve?
Yeah, it's a piece of methodology for reasoning about a special kind of information, indexical information, which is information about who you are, what time it is, or where you are, sort of self-locating beliefs, which raises some distinct puzzles compared to the normal kind of information that just describes the structure of the world. So I think it maybe originally came up in the context of cosmology, where if you have a big universe, maybe it predicts the theory about what the structure of the world is, maybe predicts that there are a lot of observers observing many different kinds of environments and histories and so forth. And if we want to derive some observational predictions from that kind of theory for what we should observe, then you need some step from the model that says this is what the large scale, perhaps infinite universe says. There are all these observers observing different things. So what does that actually predict that we should find when we look into our telescope or whatever it is, given that there are so many different kinds of observations that would be made? So that's one place where this kind of anthropics could come in. And then there are other applications in evolutionary biology, in sort of various philosophical puzzles, for simulation theory, which we might get to.
Yeah, I'm curious if you've heard of the, I think when I was trying to look at the history of this, obviously there's many applications in cosmology, the Copernican principle, sort of one of the versions of this that we use in astronomy a lot. But there's the German tank problem, which I think was, I don't know if this is urban legend or if this is real, but there was the idea that the Allies would look at the numbers on German tanks, and if it was like 327 or something, it had like a digit printed on it, then they use that to estimate how many tanks the Germans were producing to then adjust their manufacturing processes. Have you heard of that case before, or is that just sort of urban legend?
I've heard of some similar thing like that. So that's a kind of a form of statistical reasoning that I guess is kind of parallel to anthropics, in that you think of this thing you're observing as a random sample, and presumably you observe a random tank from the population of tanks, right? And then you can make inferences from that.
Yeah, and I guess in discussions of anthropic reasoning, there's two tools which often come up in these discussions, and one is the self-sampling assumption, or SSA, and that's, at least in astronomy, I think that's the one that we see being used most often. But then there's also the self-indication assumption, the SIA. I get the impression historically that kind of emerged later, but maybe we could just start by sort of explaining what's different about these two assumptions, and what are there any kind of simple examples you can give us that might distinguish how they vary?
The self-sampling assumption is basically the idea that you should think of yourself as if you were a randomly selected sample from some reference class of observers. In the simplest case, this might be all observers. If we assume that certain things are observers, some are not. And then you should reason as if there was like a kind of uniform probability distribution of you making any particular observation or finding yourself in any of these slots. So if in the context of a cosmology, imagine some theory that somebody has come up with that says that there are sort of, 90 blue planets with people living on them and 10 red planets with people living on them, scattered across a vast cosmos. Now, what should you expect to find when you look at the color of your planet? You should expect with 90% probability to find the thing that 90% of observers observe. And if you find the other thing, then that would be some probabilistic evidence against that cosmological theory being correct. So that's the self-sampling assumption. The self-indication assumption is the idea that you should reason as if you were a randomly selected set of observers that include not just the actual observers that some theory predicts, but possible observers, which has the main consequence that you should update on the mere fact that you're alive, so that the fact that I'm alive makes it more likely that there are a lot of observers in the world. There are sort of more slots for me to have been born into. I'm born in, so probably a lot of people were born into the world, according to the self-indication assumption. And that is relevant for example, if we look at something like the doomsday argument, which
Yeah, I was
maybe
just
we'll
going to
get
bring that
to,
up. Yeah.
but it also has various counterintuitive implications if one accepts. So I should say that something vaguely like the self-sampling assumption, the first one, I think needs to be accepted to get sort of reasonable results out of cosmological theorizing and other applications, although the exact version of that is still murky. The self-indication assumption is more controversial, and some people accept it and some reject it. And it's less clear whether we should accept that.
That's interesting. Yeah. So the reason, connect back to the doomsday argument that you bring up there, and I'll give you a chance to maybe explain that as well. But my real question about doomsday is that it seems like if you apply this SSA, this self-sampling assumption, you do end up with these kind of catastrophic predictions for the fate of humanity. And I'll let you explain exactly how that works. But if you use the SIA instead, it seems to almost diffuse and cancel out some of those catastrophes. And if the self-indication assumption is on more precarious ground, does that give some wiggle room for the doomsday to be because I think a lot of people have like a real resistance to doomsday. It is uncomfortable and they don't like it and they're looking for a way to diffuse it. So maybe my real question is here, what does the doomsday argument really teach us about these two approaches to anthropic reasoning?
Yeah, I think you're right. The self-indication assumption, the second, was kind of rolled in more or less to get rid of the doomsday argument. Well, maybe should I first explain just briefly what the doomsday argument is? Or so maybe it's easiest to explain via an analogy. So suppose you have a big urn put in front of you, and you're told it contains either 10 balls or 100 balls, and in each of these possible urns, they're numbered from 1, 2, 3 up to the total number of balls. So each ball has a number printed. So then somebody flips a coin and selects one of these two possible urns based on the outcome, right? So now you're asked, what's the probability that the urn contains only 10 balls? So you say, well, 50-50. It was like a fair coin. Now, let's suppose you reach into this urn and pull out the ball, and it's ball number 7, right? Then based on normal, uncontroversial Bayesian reasoning, you should update now. So now it's more likely that that urn only has 10 balls, right? Because it has a higher conditional probability of getting ball 7 if there are only 10 balls than if there are 100. So you update that and you get an elevated posterior probability of that. So that's all uncontroversial. Now, the doomsday argument is the claim that you should reason in an analogous way, but where instead of two urns with balls, you have two hypotheses about how many, say, observers or humans there will have been throughout human history by the time eventually the human species goes extinct. So let's say one hypothesis is that maybe there will have been, 500 billion in total. Maybe we blow ourselves up with some new bioweapon, in 100 years or something like that. So that's hypothesis one. And then another hypothesis is, no, we'll survive, colonize, solar system and live for a long time. Maybe 500 trillion humans will have lived in total. Like, obviously there are more hypotheses, but the structure doesn't depend on that. We can simplify it, just consider these two different ones.
Yeah.
And then we have some prior, like maybe 50-50, like in reality, we'll take into account our guesses about nuclear war and bioweapons, and maybe we think probably it will last for a long time, but there's a 5% chance of it ending early. Doesn't really matter. But then the key step here is that now, just as in the case of the urns, you selected this random sample, ball 7, and updated on it. So too, should you, according to the doomsday argument, update on the fact that your birth rank, your sequence in all the humans that have been born is, around 100 billion or so. That's the number of people who have lived before you. So that's kind of unsurprising. If there will be 500 billion in total, that's like a pretty typical type of number, right? But if there going to be 500 trillion, then your birth rank would be extremely early. And so just as
you're
getting
at the beginning of the story.
So just as getting like a ball as low number as 7 is kind of improbable if there were 100, let alone thousands of balls. So similarly, we should think it's unlikely that we would be so early if there were in fact going to be very many. humans. And so then you get this systematic update in favor of doom soon, like hypotheses that imply that there will be fewer people in total will have their probability increased by this line of reasoning. And so that is an unpalatable implication. And so then people have tried to refute this in different ways, historically, in sort of the 90s, and like a lot of papers written thinking they have come up with a clever refutation, and a lot of those just failed. They were confused or were easily rebutted. So it's like stronger than it originally seemed, this argument. And this assumption, the self-sampling assumption that you should think of yourself as a random sample, it might seem kind of unmotivated, but in fact it looks like in various other thought experiments and in some scientific applications, it looks like you need something like that to sort of get common sense implications. So then one maybe bad reason to reject the doomsday argument is like we just don't like the implication that we probably will go extinct soon.
We give it a low prior out of just preference.
So that doesn't seem to have much epistemic relevance, but it also seems just counterintuitive. Like it sort of seems a bit fishy that you could get such a strong implication about what's going to happen in the future and how big the risk of new biological weapons are and stuff like that, just from thinking about, your birth rank. That it seems like how can that piece of evidence imply stuff about all these other things that seem so unrelated? That's a little suspicious. And one way to bring it home is if you think of a more extreme version of the doomsday argument. So imagine if there were like Adam and Eve, like the world is created, there are the first two people alive, and they know they are the first two people, and they can then reason, like they might think, should we engage in carnal embrace? And that like maybe they have been warned that there would be bad consequences if Eve gets pregnant and they fill the earth with progeny. And so maybe naively they would think there's like, if they have intimate relations, maybe there's a 10% chance that Eve gets pregnant, right? So they think, okay, that seems too risky, given we've been warned what would happen. But then they have this kind of doomsday argument thing, and they think like, well, if she does get pregnant and then the earth will be filled with our progeny, there will be billions of people. Like, what's the chances we would be the first two in that scenario? It's like almost like 1 in a billion, right? So so therefore she almost certainly won't get pregnant, and so we can go forth. And maybe that's what the snake said. And that seems even more counterintuitive, because it just seems ridiculous that they could be so confident that she won't get pregnant, even if they knew all the facts about biology and like how sort of mechanics of that works. So then this might be a slightly stronger reason to reject the doomsday argument, that it just seems to lead to intuitively incorrect results. Not that we don't like the results, but that we don't believe the results. Right? So like a more epistemically justifiable ground for rejecting it. But then you think, how could you reject it coherently while still getting sort of the scientific applications to work out? And then that's where the self-indication assumption would be helpful. So if you imagine Adam and Eve adopting the self-indication assumption, they think, well, the fact that we are born would be much more likely if there were many people born into the world, if there are billions, than if we were the only ones. And so it turns out that this initial probability shift in favor of there being many people that you get if you accept the self-indication assumption, exactly cancels out then the doomsday argument shift in favor of there being fewer that they get when they update on discovering that they're actually the first. So you cancel out the doomsday argument, which is neat. But then you have a different set of problems.
We'll get to those, because I want to talk about the presumptuous philosopher and things like that.
Yeah.
But I guess just to, because it took a while for us to expound upon exactly what doomsday is saying, and there are all these disagreements and tensions between these different ways of thinking about this problem. It's an old problem, but what do you personally like really take away from all of everything, all the ink that's been spilt about this problem? What do you think is the real lesson from the doomsday argument?
So if we live in a big world, which looks quite likely on independent grounds, like it's not then the case that there either just is like a small version of the human race or a long-lasting big version of it, but instead there might be possibly infinite, where there is very, very large. Now, if you have that picture, then even if you don't accept the self-indication assumption, just the self-sampling assumption itself would imply that a priori are more likely to be born into one of the bigger species, the ones with more members, because those are all actually existing human beings or observers. So if you're a random sample so if you're a random sample of all of these actually existing beings, it's more likely to be in a big subset than in a small subset, right? Like aside from more specific evidence than you get. So you already at that point have this shift in favor of, say, the human species being long lasting. That then gets canceled out when you update on us being early. And so that's one consideration there. And I think, I think there is still a bunch of places where I think we are confused about how to reason about these the methodology of anthropics, I think, still has points of confusion, and also how to reason about these really big picture. Like particularly you start to roll in infinities, which looks like you need. There are all kinds of paradoxical consequences that arise from that, and probably our current thinking is still a bit muddled on exactly how ultimately to resolve that.
Yeah, for sure. If you have an infinitely sized universe, then it's like in monkeys on a typewriter. Like everything will happen to some degree. So then, what do these statistics even really mean in that case?
So you need a measure over that, right? And then you need to define that measure, and then you get the consequence that if you just moved people around without changing anybody's local environment or brain state, you could sort of change the probability of being one or the other of these. And so there's some stuff that we still seem to be a bit confused about.
So there are actually some successes. At least, I mean, I'm certainly aware of at least one clear success in cosmology of an actual prediction with anthropic reasoning. And it was with Steve Weinberg, a cosmologist. So maybe you already know about this, but he predicted the cosmological constant, I think back in the 80s, the late 80s, 1987, I think it was. So this is before the actual measurement of the accelerating expansion of the universe, which of course happened, and was won a Nobel Prize for. But he predicted the cosmological constant based off sort of anthropic arguments, and he was really actually using, he didn't call it the SSA, but it was essentially the SSA, I think, if you read that paper. And so and what was remarkable is that he got within a factor of, I think, 5 to 10 of the right answer, which, given the scale was, many, many, many orders of magnitude, it was quite impressive. Really the argument was, if the cosmological constant can't be too big, otherwise the universe would basically explode too fast and structure wouldn't form, and it can't be too small or negative, because especially if it's negative, actually leads to the universe collapsing too quickly for intelligent life to develop. And so just based off those bounds alone, you can already kind of get an estimate. And he at the time, it was kind of controversial. Everyone thought the universe would be static and unchanged, or not accelerating, certainly, that it wouldn't be this extra force of dark energy. So it was a big deal to stick your neck out and predict that there'd be a positive cosmological constant. So I'm aware of that as one sort of success. Maybe you can comment on that. But are there other successes in anthropic reasoning that we can point to and say this is why this has at least some vindication for being a credible way of reasoning?
Yeah, I mean, I'm not sure I would. I mean, so it depends a little on how you define anthropic reasoning, and there's whether that could be claimed as a success for the more ambitious forms of anthropic reasoning, because obviously we know that we exist. Everybody would agree on that. So clearly, the universe, whatever has properties it has, have to be such that we exist, like just as a sort of logical implication, right? Mm-hmm. So we know all kinds of stuff. We know that there's water, so we know there's an Eiffel Tower. So our best theory of the universe has to be compatible with there being an Eiffel Tower, and all kinds of everything we know the universe has to be. Otherwise, we can rule it out. I think where it would come in is if we try to compare or evaluate the plausibility of, say, multiverse theories, where some particular cosmological parameter seems fine-tuned to allow, say, intelligent or human life. We might think that puzzling and look for an explanation, say the gravitational constant or the fine structure constant. And then one possible way of explaining that is by saying, well, look, there's actually this ensemble of universes, like reality creates all of these different ones. There is no fine-tuning at that level. It's just randomly generate a huge distribution with all kinds of values of the cosmological constant and fine-tuning constant. Then, of course, if you do that enough, some will, by just random chance, happen to have exactly the value that allows observers to arise, and then the anthropics would come in and saying, well, if that's your theory of the structure of the world, that theory actually predicts specifically that when we look out, we will find this exact, apparently, but not actually fine-tuned value, because those are the only parts of this large ensemble that are observed. So the theory gives high probability to our predictions, meaning it's kind of supported by our observations. If you didn't have that anthropics, then you might say, well, no, you need a theory that says that only this kind of universe exists with these particular parameters. You might look for some particular theoretical mechanism that would make it more likely that the fine structure constant has this precise value. And so like your plausibility judgment as between these two different explanatory approaches or theories about what the large-scale structure of the world looks like will depend on your view on anthropics. And I think the multiverse explanations are, in fact, supported because they could potentially explain these apparent observations of fine-tuning without actually requiring fine-tuning.
Okay, well, I appreciate that answer, and I think I learned something there. I mean, because I think I would have operated under a definition of anthropic reasoning as something like probabilistic reasoning conditioned upon our existence, something like that. But it sounds like you wouldn't. You would want to maybe a little bit extra on top of that. How would you, just to distinguish, why Weinberg in that case you wouldn't consider that anthropic reasoning? What would be a clear-cut definition you would offer in your classes for what anthropic reasoning is?
So it means because you wouldn't need the self-sampling assumption specifically. It doesn't matter that it needs to have that value in order for us to observe. Like it could be for any other fact that we know is true. If we could derive from that the fact that gravitational constant or the cosmological constant has to have a certain value, it would work just as well. Like if we observed some feature on Pluto that it has, a certain mass, that we could exist if Pluto had a very different mass or like a larger or smaller, but nevertheless we happen to have looked at this. If that somehow implied that the gravitational constant has a certain value, then the inference would go through just as well. In order just to make that prediction, you wouldn't need any of this machinery.
Yeah. I actually use the example of not Pluto, but Neptune, Uranus quite a bit when I talk about the Copernican principle. I get a little bit frustrated sometimes when some of my colleagues speak about the Copernican principle on the Earth, and they say, well, Earth has life, therefore life will be common in the universe. It's a very typical kind of circular argument that is sometimes used. But, the Earth also has oxygen and water, but that doesn't mean that all the planets in the solar system should therefore have oxygen or water and necessarily even be abundant. But the fact is we have our solar system does have a Uranus and a Neptune, which, as you kind of allude to there, have no bearing as far as we can tell in our existence whatsoever. And so in that case, I'm quite comfortable to use anthropic reasoning in that sense, or, whatever you want to call it, self-probabilistic reasoning. And it works out quite well because there are lots of Neptunes and Uranus type planets in the universe. That's actually a good application of it.
Yeah, so you could regard it as a sort of correction of the Copernican principle. Like rather than assuming that what we observe is typical, it would be closer to correct to saying that what we observe is typical of the parts of the world that are observed, which might not be typical of reality as a whole. I mean, in fact, we know most of the world is just empty, ultra pure vacuum, right? With no people there or looking, as far as we can tell. And we live in this very special little crust of biosphere, which seems very untypical. So but it might be quite typical for the kinds of places that are observed by beings like us.
We'll be right back after this short message. Today's episode is supported by our friends at Incogni, a fantastic service that helps protect you and your data online, a vital counterweight to data brokers, skimmers, and bots. It's really kind of sad and ridiculous that there are now thousands of companies out there who are profiteering off harvesting your data and then selling it on without your permission. But the law does protect us, and each of us has the legal right to write to these companies and demand that they delete your information. The problem is, it would practically take hundreds of hours to do this. So this is where Incogni comes in. They scour the internet for your information, and you can either confirm or deny possible matches, and then they use the law to remove your information from those databases. And this is often very sensitive information. I'm talking home addresses, medical history, and even social security numbers. Incogni has a new killer feature called custom removals, which lets you copy and paste any links where you find your personal information online, and then they take care of the rest. So to fight back, use my exclusive link incogni.com/coolworldspodcast to get 60% off by using my code coolworldspodcast. Once again, head to incogni.com/coolworldspodcast and use the code coolworldspodcast for 60% off. Now back to the episode. So this kind of bridges a little bit to simulation argument, I think, through, because I see the presumptuous philosopher as a kind of a bridge here to simulation, because that certainly implies a big world, a big universe with many observers in it. So maybe we'll use that opportunity to introduce presumptuous philosopher. So that's a kind of a challenge, I suppose, with the self-indication assumption that if you have two theories, A and B, let's say they're cosmological theories, and one, B produces a trillion observers, or a trillion observers, and A produces just a trillion observers. And so the ratio of those two, by the SIA, you'd strongly favor the big universe, B. And so the problem is, I suppose, that if cosmologists come along and they start making measurements that hint that A is the correct answer, and then it becomes strong evidence that A is the right answer, it becomes almost impossible for them to overwhelm that prior, because the prior prejudice for the big universe is so overwhelming that you just would ignore the evidence. So this seems like a formidable issue for the self-indication assumption, which, if you get rid of that, it kind of diffuses one of the counter arguments to doomsday. So I'm kind of curious about how serious of a threat or a flaw you consider presumptuous philosopher to the self-indication assumption reasoning.
Yeah, so that's the Charybdis, right? If the sort of doomsday argument and the Adam and Eve implication is the Chilla. And so either way, it looks like you're running into a lot of rough waters with this reasoning, right? Whether you accept or reject the self-indication assumption. And so this is what motivated me in my earlier work. This is back in the early 2000s. My doctoral dissertation and later the book Anthropic Bias was trying to get clear on the implications of these different assumptions that one might make. Because usually up to that, it was kind of frustrating. There were all these contributions to the literature that consisted in sort of being aware of one side and then reinventing the self-indication assumption, or being aware of that and then reinventing the other. But you really only confront the difficulty when you look at all of these implications at the same time. That's when you realize how hard it is to find anything that avoids them, right? If you need to sort of feel the horns of the dilemma pinching you from both sides. And so I tried to propose a theory there with a relativization of the reference class. So the self-sampling assumption in my formulation, if you recall, was you should think of yourself as a randomly selected sample from some reference class of actually existing observers. And it kind of gets too complicated to go into here, but the idea I had that first of all, you need to move from observers to observer moments, because just as you can think of yourself as a random observer, you could also think of your current observation as randomly selected from some sequence of observations made by you. And so like kind of a strengthening of the self-sampling assumption, right, to the strong self. So now you're a random observer moment. And then the idea is that when you receive this new information in these thought experiments, you observe your own birth rate rank, you're actually changing which observer moment you are. Like you're now have a different informational content. And so it might be that this new observation moment that arises when you get this new information has a different reference class that it should think of itself as randomly selected from than the same observer's previous observer moment before they got this information. And so the hope then with that is that you can avoid both of these counterintuitive implications, the Adam and Eve implication, doomsday argument on the one hand, and this presumptuous philosopher implication on the other hand, which does seem to require something like the relativization of the reference class.
So let me ask then, these SI is obviously valid as or a potent issue when we're talking about big universe theories. And simulation argument is one of those ideas that you're most well known for and certainly invokes a very big universe. So if we go back, I think this idea was like 2003 that you wrote this paper with your trilemma, where you first stated this. So maybe we can start there. Maybe you can just state what the trilemma it really says, because I think a lot of people interpret it to mean we are absolutely simulated or something. That's not really what you originally wrote. And second, how has your, because that was over 2 decades ago, how has your thinking evolved on this simulation argument since its inception?
Well, the trilemma first is that at least one of the following 3 propositions is true, where the first one is we will almost certainly go extinct before attaining technological maturity, in particular gaining the technological capability to create vast numbers of ancestor simulations, like computer simulations of people like us or our historical forebears. So that's one possibility. The second proposition in this trilemma is that there is a very strong convergence, so that virtually all civilizations that do attain technological maturity lose interest in creating ancestor simulations. So even if by spending just a tiny fraction of their resources, they could create vast numbers of of simulations, they still choose not to even devote a tiny fraction of their resources to that end. So they're not even slightly interested. And the third proposition is that we are almost certainly living in a computer simulation. Not in a metaphorical sense that you can view physics in information processing terms, but in the literal sense that there is some advanced civilization that has built some powerful computer, and that you and I right now are implemented within that computer, and our world is a virtual reality simulation run on that computer. So at least one of these 3 is true according to the simulation argument. I think it's held up very well, and I think it's easier for people to credit it now. Partly, I guess, just because the passage of time and not the failure to find sort of key flaws in it. We can discuss that, because certainly there remains discussion around it. But maybe more importantly, I mean, you see year by year, for example, virtual reality technology becoming better, and you have more and more realistic virtual, like it's kind of easier. Back then, it was like a harder leap of imagination to think that it would ever be possible to create this kind of computer simulation. That from the inside you couldn't tell right now, but you see better computer graphics now with AI really advancing. It makes it easier still, I think, to conceive that at some point you actually would get this capability, or like superintelligences would be able to create these simulated minds. So there's like a little bit of imagination difficulty that has been reduced.
Yeah.
And of course, in terms of, so there is this trilemma. The simulation argument itself doesn't say which one of these is true. But of course, the closer we get to technological maturity ourselves, like the less likely the first of the propositions is to be true, right? It's less likely that we will go extinct before reaching technological maturity. The nearer we approach it, there's just like less places left for us to sort of fall off the wagon, although there still remains some. So it sort of shifts probability mass over to the remaining 2.
So maybe I can ask you, because we'll get to maybe some of the ongoing discussions that have happened on a more technical level about it. But this came to mind because I actually received a letter about this recently, and I'm sure you must have received many letters of your career from people who've heard you speak about this, and at a human level are unsettled and disturbed by the implications of the simulation argument. And I'm just sort of curious when I get this email saying, can you please give me a reason to not believe in the simulation argument? And they're searching. They really find it so unpalatable. They want it not to be true, and sometimes they're even in a kind of a state of crisis about this. I wonder sort of how. Obviously, we're not therapists. We don't know how exactly to deal with that. But have you encountered those kinds of reactions, and how do you respond in turn to those?
I certainly have encountered. I mean, I get a lot of email. Usually they're not that, but certainly over the years. Now, I think in most of these cases, the likely thing that's going on is that they have, for some independent reason, some difficulties or mental health difficulties, and then this maybe appears to give a framework for just as in the previous era. I mean, maybe like during the Freudian era, they might have said, "Oh, I now seem to remember these childhood abuse memories," or before that, maybe they would couch it in terms of being demons that were possessing them, and so it's like, and is it like the internal phenomenology gets projected onto this new terminology? Maybe I think so. That's probably more often the case than that it actually being caused by specifically these theoretical convictions.
Yeah.
And then they should seek help from mental health professionals and so forth. Insofar as the concern is specifically with the simulation hypothesis, I mean, I think even if we are in a simulation, probably the best guide to what is likely to happen next in the simulation is kind of similar to what we would rely on if we were not in a simulation. That is, like, we observe patterns in our reality and extrapolate them, and whether those are simulated or not simulated, in either case, that's kind of most of what we have to go on. And so I wouldn't, for example, say that if we are simulated, then nothing is real or the world is not real. I think that even if we are in a simulation, the world would still be very real. Our actions would have real consequences. Other people probably would still be real and have experiences and so forth. So to a first approximation, probably you should proceed the same way as you would if you were not in a simulation. And there might be more subtle things on the margin that you would do differently, but that would be like the first approximation. It's also worth taking into account that there are many people who understand the simulation argument at a deep level and take it seriously, but who are not reacting in any of those ways. And so it doesn't seem to be any sort of logic implication of the simulation hypothesis that the world is very depressing, or that you should become crazy, or like, so it might be that their interpretation of it is not correct, considering that there are like some of the smartest people I know who've thought carefully about this don't draw those implications or find that it has those sort of emotional consequences.
And I'm curious, just as the architect of this, and as the personally for you, do you try to remain agnostic about your own personal epistemic belief about whether you are simulated, or are you convinced that it is the most probable solution?
I don't try to remain agnostic. I don't know that in general one should be trying to pick one's beliefs on the basis of one's wishes or values. But I mean, at least the first cut approach to rationality might be to sort of try to, as accurately as possibly, model the world as it is and your place in it, and then your values come in after that to sort of figure out what to do in light of that. Now, I have in general punted on the question of precisely like what probability would I assign to the simulation hypothesis, like the third of these three propositions, and refrained from putting a number on that. Which I will stick to in this conversation as well. I have said, and I will say, though, I do take it, I think it is a serious possibility, accorded significant credence. But other than that, it might also be the case that I alluded earlier to the fact that we still seem to be a bit muddled or confused conceptually about the nature of anthropic reasoning and this really biggest picture thinking. And it might be that that also applies ultimately to some of these questions related to simulation theory. And in particular, if you think that there are many versions of you, some simulated, some not, with different consequences over base reality. Maybe you superimpose on that the kind of Everettian many worlds interpretation, and you just have this like hugely complex thing where there are different forms of experiences or decision relevant processes taking place with different measures and in different places overlapping in terms of their intrinsic qualities, correlated with each other in terms of the decisions they make. It's not 100% clear what the distinction ultimately cashes out to between being in a simulation and not being in a simulation. In that kind of, it might be that you're both in a simulation and not in a simulation, like different copies of yourself, as it were, are existing in these simultaneously in these different parts of reality. And maybe you should think yourself more as the sort of cohort of all of these processes that exist with different measures that implement your kind of decision algorithm or something like that.
Sorry, I was going to say, I wonder if the universe is computational, for instance, that's it could have an inherently computational nature to it. It becomes a little bit harder then to even distinguish what we even maybe mean by simulated versus a naturalistic existence.
I'm not sure the computationalist point itself would have that. It could be that basic physics, is Turing computable or whatever, and yet it could be the case or not be the case that in that basic physics, some civilization arises that creates a powerful computer, with cooling fans and electricity cables going in, and inside that computer they might, simulate climate models, or they might simulate the stock market, or they might simulate people like us. Like that seems to be a separate question from whether the underlying physics.
Yeah, maybe a better example is like thinking about like the hologram idea, like the idea that the universe could just be a projection of a 2D surface into 3D space. And so I think in physics, that's just, there's many examples. You think about the quantum level and our existence, but there's many examples in science certainly where we encounter ideas which may feel existentially threatening in terms of our identity and who we are. And to that degree, the simulation argument seems like the strongest confrontation of that notion, but it's also, at least it feels like to me, part of a continuum that we've already encountered many times before in science about really questioning who and what we really are anyway.
Yeah. Although I think with the simulation argument, the way I see it, the main punch is not so much questioning the metaphysics of who we are, but more that it introduces a wide range of possibilities for what might happen next to us. So it's not just like, whether I'm information or whether I'm quarks or whether I am some other like substance. It's maybe philosophically kind of interesting, but it doesn't really have concrete practical applications. Probably I should do the same thing, whether I'm energy or I'm quarks or I'm matter or I'm some whereas with the simulation argument, it does introduce these different possibilities that did not otherwise seem on the table. For example, the world could pop out of existence, our world, at any moment, right? If the simulation is terminated. Whereas if we're not
I'd say that in physics we have similar ideas though, right?
Sorry?
I'd say in physics you can imagine like a false vacuum decay, similarly just sort of that destroying everything.
Yeah, that would be more, if you thought that there was a high probability of this kind of vacuum decay happening in the near future, then that would be more practically relevant. Like maybe you would want to save less for the future and just kind of live more for today, if you thought that vacuum decays happen every 6 months or something like that, right? And other things that also the simulation hypothesis would introduce is very like possibilities of sort of afterlives and stuff that, unless you have a theological conception, right, from a sort of materialistic perspective, seem really perhaps far-fetched. Outside the simulation hypothesis, like much more plausible, and it might also give us information about. So you remember the simulation hypothesis was only one of the three, right? So if you sort of think that's not the case, then it might tell us other relevant things about the structure of reality and our place in the world, like the level of risk in the future or the motivations of advanced civilizations and stuff like that. So I see it less as sort of metaphysical claim or theory, and more as a sort of substantial claim about the structure of the world and the likely future trajectories that we might have.
Understood. Okay. So let me use this as a segue to talk about existential risks a little bit, which is another thing you've written about extensively throughout your career. And I think obviously simulation argument touches on this because certainly in ancestor simulations, you might imagine that these simulators would be most interested in simulating particularly dangerous parts of history or particularly interesting parts of history, however you define interesting. And certainly feels to many of us like we're living in unusual times right now. Like the world just feels in a very delicate balance right now. And so one might even make the case that to invoke that as a piece of evidence to some degree for the simulation argument. So I'm curious what your take on that would be, and also whether you would agree with the premise that we do live in unusually dangerous times right now.
Yeah, certainly I think unusually interesting times particularly plausibly relevant for simulators to be interested in that say the development of machine superintelligence looks like it's could happen in a relatively short time frame. So it might be that this period of human history is particularly influential in shaping the long-term outcomes of human civilization, in that maybe superintelligence, whether it happens with what values, goals, and its nature might be sort of determined in the next number of years, and that might be something of particular interest and relevance to a wide range of simulators.
There was a document called AI, was it 2030 or 2032? Maybe you know the one I'm talking about, that came out, I think about
2027.
Is it 2027? Yeah, it had a specific date. Yeah, and
Yeah.
it was a very dire prediction of the impact of two kind of pathways. Of how one was maybe more optimistic, but this kind of race between especially the US and China to develop AGI as fast as they can was essentially unhealthy, right? Because this capitalist motivation to beat the other one led to a willingness to drop some of the safety precautions in AI development. I'm sort of curious, do you also share that concern with the current era of how fast AI is developing, or do you think that's been overstated?
Yeah, no. So so the AI is like maybe the main thing I've been thinking and working on in the last, 15 years or something. Like it's a kind of key focus. So yeah, I have a lot of thoughts about that. I do think there are will be serious risks associated with this development of AGI and then superintelligence, including existential risks, and that we should take those seriously and work hard to reduce them. I think ultimately I favor going forward and developing superintelligence, but that we should be really careful when we do it. So that's kind of in the abstract. I think the ideal world would be one where we all came together and did this carefully together in like international collaboration with all the best people, trying to check everything for safety. And in the world that we're actually in, that maybe looks hard to achieve. And so then it's a question of second best, given reality as it currently is. Where on the margin should one try to nudge things in a way to increase the chances of a good outcome? And there's like it's a complex thing, but I think there's like a bunch of different challenges there. So one is this alignment problem, right? Like developing scalable methods for aligning arbitrarily powerful AI systems so that they do what the people developing them intend for them to do, as opposed to something that is harmful to humans. But then on top of that, we have like a governance problem, right? Like to make sure that this powerful technology is even if it's controlled, is then used primarily for beneficial purposes rather than to like wage war or oppress each other or do other harmful things. So that's like in its own right, like a big bucket of challenge, right? And then I think there's like a third one, which is ultimately these digital minds that we're building, I think will have various degrees of moral status. That is, it matters intrinsically, not just what they do to us or what we do to each other using these AI tools, but also what we do to them. And for the future to be great, it should be good for both like humans, non-human animals, and for these digital minds that might constitute the majority of the population in the future. Like most minds will be digital. So that's a huge challenge as well, both practically and philosophically. What does it mean to treat these digital minds well? I think that challenge now is roughly where the alignment problem, the first one, was back in 2014. That is, some people are talking about it a little bit on the internet, but it's a little outside the Overton window still. And we need to move it to the sort of more serious conversation stage. And then finally, there's like a fourth challenge, which has received even less attention, but I have this recent paper draft on it called AI Creation and the Cosmic Host. And this is basically making sure that whatever superintelligence arises out of our civilization will get along well with other superintelligences that might pre-exist out there in the big universe, either built by other aliens, or, of course, if we are in a simulation, the simulators, or if there are like, if some sort of theological conception of reality that could be supernatural super beings. But whatever this kind of cosmic host, this bracket of super beings that might exist when we create our superintelligence, maybe the most important thing ultimately is to make sure that it kind of gets along with this peer group that it might be joining, which we understand even less about exactly what to do, but it does look like a key thing that we need to get right.
Well, that's a wonderful segue for my last question for you, because I want to be respectful of your time. I know you have to sign off soon. So this idea of connecting back to the greater universe, of course, of deep interest to someone like myself, an astronomer who is interested in looking for life in the universe. And of course, it circles back many of the ideas we've spoken about today to the Fermi paradox of the great filter with these existential risks, the nature of being simulated, perhaps, and why maybe as an explanation for the apparent loneliness that we see, and also with the emergence of AI, how does that influence our thinking about the search for intelligent life or technological life in the universe? So I guess I'm sort of curious how you combining your both anthropic reasoning of our apparent silence and the emergence of this potential superintelligence on the Earth, how does this influence your view of the most likely solution to the Fermi paradox?
I've never really seen the Fermi paradox as particularly paradoxical. Like a paradox is usually when there are sort of two apparently strong arguments that collide,
Right.
and
Yeah.
point in opposite directions. Here, I don't see what the opposing argument is. Like the
Yeah.
obvious
There's definitely a
explanation.
semantic discussion to be had there, but for
Yeah,
better or worse,
because
let's
it seems
just
that
call it that.
for all we know, it seems perfectly plausible that it might just be really hard either to get simple self-replication going, even if you have like an Earth-like planet, or maybe there's a slightly later step to eukaryotic life from prokaryotic life. It took like a billion and a half years on Earth. Maybe that just required like some ridiculously improbable random thing. It's like several different molecules coming together in exactly the right
Sure.
direction at the same time, and maybe that
So
is
a great filter that's behind us in that case.
that seems perfectly consistent with everything we know, and in no way a stretch. Now, that doesn't preclude that there could also be a filter ahead of us, or that there could be some other simulation hypothesis related explanation or something like that. That might also be the case, but I don't think we are sort of pressured into believing that just from failing to observe aliens, because there's this alternative, very natural, obvious explanation available, that it's just improbable, like hard, even if you have Earth-like planets. Now, where it would start to come under pressure is if we discovered independently evolved life on other planets. Like if we would go to Mars and we find bacteria there that were like, that didn't look at all like Earth bacteria, like there's like had a different biochemistry, had evolved differently. Like imagine if we discovered that would rule out some of the places where the filter could be in our, like if we discovered more advanced life form, like extinct squirrels in Alpha Centauri or something like that, right? Then you would start to build the pressure. Like there are all these planets could get all the way to squirrels, even just within this small bubble of the universe. Why then haven't we seen aliens coming from afar? And at that point, you would start to need some particular alternative account for that, great filter or zoo or some other thing, right? But at the moment, we haven't seen that. So,
but I guess just to make this question a bit more pointed, because even, I mean, I think in your mind maybe the idea of superintelligence is an old one, but I think for many it's kind of a new one when we're thinking about the development of AI. And I'm sort of curious if you move from a position of, we are the smartest thing more or less in the universe to all of a sudden accepting that there's this potential for a super intelligence in terms of AI or machines of some kind doing thinking, intellectual labor, then does that not exacerbate or put more pressure on the fact that, hold on, why don't we see stars being engineered or black holes being used as machines, things like this? Because you might imagine that's maybe out of the realm of our dreams for even the next century or two, but for a super intelligence, surely its capability would be far vaster.
If they were around in this little corner of the universe, but I mean, we don't see that much of the world, right? It's just this some tens of billions of light years bubble. So if life is improbable, one of the early steps, it could easily be extremely improbable, not just sort of 10 to the power of, minus 10 improbability, but why not 10 to the power of minus 40 or 10 to the power of minus 80 or because if you imagine some system of molecules that have enormous number of degrees of freedom, if there were some coincidence that just required a few of these to come together right in the right way, that could easily just put your preferred exponent right in the number, like that seems as likely as any other exponent, like within a very large range. So you could easily have a model, it seems, where the closest other place where any form of life arose at all would be like 10 to the power of 50 light years away. Like that seems consistent with what we currently know about chemistry. Or 10 to the power of 200 light years. I mean, there's just like a lot of space there. So
you think that's the easiest place to put the solution right now? It sounds like.
Well, it's one big obvious place where the solution could easily be. Now, it doesn't mean that it necessarily is there, but there doesn't seem to be any paradoxical force in denying that. If you say,
I love that. I think that's a great place to motivate astronomers as well, such as myself, because we do have experiments coming online that could potentially in our lifetime answer this question of actually conducting a search for biosignatures in other exoplanet atmospheres and certainly in the solar system as well. So that would be a profound test of this idea and perhaps make the biggest difference in terms of moving the needle about our belief system on this. So astronomers should certainly talk to philosophers more, because I think there's a lot of interesting interaction about the right questions to be asking and where to put pressure on. So I'm going to
recently in some workshop that on thinking about what the signatures of advanced life would be if you imagine sort of them building Dyson spheres and stuff like that. What exactly would be the sort of remote signatures of that in terms of thermal radiation and other characteristics you might be able to see from afar if you had some advanced civilization doing sort of astroengineering using...
Oh yeah, I mean, we've surveyed, there's 100,000 nearby galaxies that we've surveyed for being turned into Dyson spheres, and none of them look that way. And there's about of order of several million individual stars we've checked for Dyson spheres. So it appears like this is not something that is frequent in our neighborhood. In a very large megaparsec scale. This is not something which happens locally. That's an interesting data point, but again, it's a little bit speculative whether this is an inevitability for such a superintelligence to do. But it is at least a data point that we can apply from science.
Yeah.
Well, this was wonderful, Nick. I really appreciate your time. I hope I can get a chance to talk to you again in the future as well, because there's so much more I could have talked to you about. But I want to be respectful of your time and just say a huge thank you for talking to me today.
Yeah, no, it was fun. Thanks, and let's catch up again sometime.
So that was my conversation with Nick Bostrom. I hope you enjoyed it as much as I did. It really was a pleasure for me personally to get a chance to talk to Nick, because I have been aware and ingesting so much of his work for many, many years, but never had the privilege of actually interacting with him directly. Now, as I said, one of the things at the beginning of the episode that I'm curious about is how you felt about doing a virtual episode like this. It's not something we've done before. I am potentially open to doing more episodes like this. If you feel like the conversation was just as productive as our previous ones, let me know, because that is useful feedback. Or if you prefer the in-conversation ones, the in-person ones, I should say, then please do let me know that as well. And, if you have ideas for guests, people that you think I should try and track down and speak to, that is also always appreciated. I have a long list of people I'd like to try and grab and sit down with, but I always appreciate hearing your thoughts as well. Now, if you want to support these conversations and the Cool Worlds podcast, as well as really the entire Cool Worlds enterprise, which includes our main YouTube channel and especially the research group, the Cool Worlds Lab, where we investigate questions kind of touching on the ones that me and Nick spoke about, such as the risk, the great filters to humanity, as well as the search for life out there in the universe and what that means existentially about who we are and our place in it all. These are deep questions that I care very much about. And of course, there's also just our bread on the table research that's looking at exoplanets, trying to discover new worlds and our place in it all. If that sounds appealing to you, if this is stuff that you want to support, then the best way to help us out is to become a member to the Cool Worlds Lab. So you can use that by using the link down below in the description, but it is coolworldslab.com/support. Once again, that's coolworldslab.com/support, where you can become a donor to my research team from as little as the price of a coffee per month. And that money really does make a huge difference to our research and also to the production of these episodes. So please do check that out. And as always, I will see you in the next episode.